So is the screen visible? Can you please confirm whether the screen is visible or not?
Yes, sir.
Okay, okay. So let's start the session then. And the recording has also been started. Okay. Good evening, everyone. Myself, Arka, and I'm working as a Prime Minister's Research Fellow in the Department of Electrical Engineering, IIT Patna. And I will be your NPTEL PMRF TA for this course on discrete time signal processing. This course is offered by Professor Mrityunjay Chakravarti, IIT Kharagpur. So moving forward with the today's content. So today we'll try to solve the quiz solutions of week 1, week 2, as well as week 3 also. Because I have seen that in week 3 also you have been graded already. And after solving these particular questions, then we'll try to solve some questions which are related to week 4 content. Additionally, I will try to cover some basics of week 4, basically the recap part, but I don't think so because today I will be solving the quiz of week 1, week 2, and week 3. Majorly, it will take most of the time. So I will try to do a recap of week 4, but I'll see that whether time permits or not. If time doesn't permit, then we'll straightly jump to the uh, solution of some questions regarding week 4. And then we'll have a short Q&A session regarding if you have any problem with the questions that has been discussed in the session. So let's start with week 1 quiz. So I will be solving each and every question as because I have seen that in the NPTEL forum, many of the students has been asked, have asked that to solve the all questions regarding all the quizzes. So I have taken each and every question that is there in the week 1, week 2, and week 3 quiz. So let's start solving the problems. Okay, so week 1, first question. The question is that they have given an xn input signal, and we need to, there is a relation that is yn is convolution between xn and hn. And hn is given, they have given another sequence hn, which is a composite sequence of u of minus n and negation of u of minus n and minus 4. Therefore, we need to find the convolution result at index 2. Therefore, what is the final result that they are asking? That is y of 2 is equals to, uh, so let me start writing the convolution equation first and then I will put the values. So y of n is equals to xn convolve with h of n. Now I can write it as hn convolve with x of n, that is from the property of convolution. Then I can write it as h of r x of n minus r. And the summation is running from r equals minus infinity to infinity with yn. Now the question says that we need to find the convolution value at n index equals to 2. Therefore, we can write it as h of r x of 2 minus r equals to minus infinity to infinity. So therefore, we can see there will be two sequence which will be multiplied in a dot product fashion, and then we'll be summing up all the sequence. So the sequences are h of r and x of 2 minus r. So let me just try to plot h of r first. So h of n is given as u of minus n minus u of minus n minus 4. Therefore, so u of minus n minus 4. So let me start drawing u of minus n. U of minus n looks like this. Let me change the color. So this is at index 0, index 1, 2, 3, dot, dot, dot. Even let me draw index 4 also. So that is minus 4, minus 3, minus 2, minus 1. So u of minus n, that means the on the positive side, on the right hand side, there will be no component. Only in the left hand side, there will be components, signal components. Then the second signal is u of minus n minus 4. That means first there is a delay of plus a delay of 4 unit. That means the signal will start from this side. That means 4, 5, And as because after that we are doing the time inversal property, that means whatever will be there in the right hand side, that will be reflected to the next left hand side. Therefore, if I directly draw the u of minus n minus 4 sequence, it will look like this. So from minus 4, I will get the sequence minus 4, minus 5, and dot dot. Therefore, this is the u of minus n minus 4 sequence, and this one is the u of minus n sequence. Now, the operation that is there to get the hn sequence is negation operation. So therefore, if I negate these two sequences, so the output that I will get is u of minus n minus u of minus n minus 4. I will get it like this. So it will start from index equals to 0, then it will go minus 1, minus 2, and minus 3. So this is our hn. And I can just write n on n and r interchanging. So let me interchange the variables. R is equals to n. So eventually the sequence will be same only. So now the first part is done. We got the HR sequence. Now we have to get the H of 2 minus R sequence. So let me first draw the XR sequence. That is, let's say this is XR. It will be 0, 1. So 0, 1, 2, 3, 4, 5. So 0 to 3, there will be positive. And in 4 and 5, I guess someone is joining. Okay, so in 4 and 5, the value is minus 1, and the rest is 0. So our aim is to get x of minus r plus 2. So let me start solving the sequence from the left hand side. So we'll look around the sequence from the left hand side view, and then we'll do the operation simultaneously. So first operation is advancing the signal by 2. So if I advance the signal by an amount of 2, therefore all the signal will be shifted to the left hand side. So we'll get the signals like zeroth sample will go to minus 2, then it will be minus 1, 0, and it will be 1, 0, 1. And minus 4, and the fourth sample will come to the second index, and the last sample, this fifth sample, will come to the third index. So this is advance by 2. Then what we have is that time inversal operation. So now if I do the time inversal operation, it will look like uh, everything will be just reverted around the y-axis. So 0 sample will be here, then this will be minus 1, this will be minus 2, this will be minus 3, and these samples will go over here, that is 1 and 2. So therefore, this signal is x of minus r plus 2, which is index of r. Now we just need to multiply these two sequences. So let me first copy this part. So I will copy this one. Okay. And okay. So we have got the x of minus r plus 2 and h of r sequence. So I can just change the variable r with n, n with r. So we'll multiply h of r, x of minus r plus 2, and we'll add all the, and this is summation is on r, and we'll add all the samples over this particular region. Therefore, the summation, therefore we can start multiplying this sample. So at 0th position, so 1 cross 1. Here all the values are 0, therefore the multiplication over this range, it will be 0. Now at minus 1 index, the values are 1 into 1. Then at this particular location, the indexes are 1 and -1, and the values are 1 and -1 simultaneously at 2 and 3 positions. So 2 minus 2, therefore 0. So the summation, so the convolution operation at index 2 is comes out to 0. Therefore, we can check the also the options also. So we can see the option C is the correct one, 0. Okay. Moving with the next question. Next question says that there is a system given y of n, which is uh, expressed as mod of xn, and xn is the input of the system and yn is the output of the system. Okay. Xn is the input of the system, yn is the output of the system, and we need to find whether the system is linear or time invariant or not, and their combination. So let's start investigating the linearity property. So linearity check, linearity check. So to get the linearity property, we need to see that whether the system is following the superposition theorem or not. So what is the superposition theorem? Superposition theorem says that if we apply the input separately, two different inputs, and we'll get some output and we'll take some linear combination of that. So we'll get some separate output for that. And if we do the same, like we take some linear combination of the inputs and we get some output, if the output at present is equal to the previous output, summation of the previous output with some linear combinations of them, so we can say that the system is obeying the superposition theorem. So let me take two different signals. So first case x1n, and then the y1n will be mod of x1n. Similarly, x2n, it will be y2n of mod of x2n. Therefore, we can take some, let's say y total dash is equals to let's say C1 y1n and C2 y2n. So it is effectively as C1 mod of x1n and C2 mod of sorry, this would be x2 mod of x2n. So this is the first response when we had applied the input separately and we take some linear combination of the output. So the output is given as this. Now, in the second case, we'll take some linear combination of the inputs itself. So C1 x1n plus C2, this will be x2. C2 x2n. So with this, I will check that what is the output. Therefore, we can check that y total, let's say y total hat of n, it will effectively look like C1 x1n and C2 x2n. So in several cases, we have seen that if there is a mod, and let us consider, we can take some general sequences. Let us consider X, the input sequences are complex signals. So we know that from the complex theory, Z1 plus Z2, the summation will effectively lead to the summation of individual modes with a less than equal sign. That means I cannot say that this properly that the summation will be just the equation equity property. That means we can have some other view. Let us consider this is a triangle, and we know that these two side, if I sum these two thing, obviously it will exceed this particular value. Therefore, I can write it as less equals C1 x1n plus C2 x2n with mod. Therefore, I can say that this particular thing, like this particular condition, is not same as the previous one. So I can just change the color over here. So I can see that here is the main concern. I am getting some different equity property. That means there is some inequality that I am getting. So I can write it as C1 Y1 N plus C2 Y2 N. Therefore, I can say that Y total of N is not necessarily equal to Y total with Y total prime N. That means Y total N hat is not necessarily it will be equal with the Y total prime N. Therefore, I can say that this system is not linear system, or this is a non-linear system, or non-linear linear system. So the first part is done. That is, this will be non-linear. So we are left. So the option A and option C are already nullified. So there will be some option in between B and D. So let us try to search about the time invariance property of. So as far as the time invariance property is concerned, so what we'll do, we'll delay the input signal and we'll check that whether the output is delayed by the same amount or not. So in the first case, let's say, let's delay the input sequence by an amount of capital N. Therefore, the signal will look like N minus N. So with this, Y, let's say hat N will be equals to mod of X N minus N. Okay. And let's say let's delay the output signal itself by the same amount. So in this particular case, we'll be delaying the output signal itself with a shift of n samples. Therefore, it means that all the samples, so yn is already given as that mod of xn. So now I am changing this n variable. This n variable is changed with n minus n. So all the variables which are represented with n, that will also be replaced with n minus n. Therefore, y, let's say, y prime of n, y prime of n minus n is equals to y prime of n is equals to yn minus n is equals to mod of n minus n. Therefore, we can see that y cap of n and y prime of n. That means in this case the input was delayed, and in this case the output itself is delayed by n amount. And as because I'm changing the index over with n minus n, all indexes will change with the same amount. Therefore, we can see that these two conditions are basically equated with each other. Therefore, I can say the system is time invariant. That means it is not changing with respect to time, or if we change the input with n amount, the output will also be shifted with n amount. Therefore, the system has two properties, time invariant and non-linear. Therefore, we'll check that which will be the correct solution for this one. So this is non-linear and time invariant. So option B will be the final answer for this particular question. Okay, let's move to the third question. So the third question says that y of n is equals to 2 to the power minus k x of k, and the k is running from mod n to infinity. So the question is that we need to find whether the system is causal or and stability is there or not with the, associated with this particular system. Okay, so causality means, so causality means as far as the signal is being concerned, so a signal which has the value, let us consider xn exists for n greater than 0 and 0 for n less equal n less 0. So for this particular thing, we can call this particular sequence xn is a causal sequence. So we'll check whether for the negative indexes, if this yn exists, then we can say that, okay, this sequence is not causal sequence or a non-causal sequence. Therefore, let us first try to see the sequence at 0th position. That is yn equals 0, 2 to the power minus k. K will run from 0 to infinity and xk. So let's consider the input sequence xn be un. So if xn is un, I can see that 2 power minus k and this will be uk and k is running from 0 to infinity. I can draw the sequence as well, how the sequence looks like. So this sequence will start from 0th position with an amplitude of 1, as because 2 to the power minus 0 is 1. Therefore, it will go like 1 upon 2, 1 upon 4, 1 upon 8, like this. That means this sequence is a decaying sequence. Decaying sequence. And if I start solving the summation, so the summation will effectively reduce to 2 power minus k is 0 to infinity, and I can still write it like this. So k equals to 0 to infinity. Therefore, this is a GP series. This is a GP series, and most importantly, this is an infinite GP series with a common ratio of half, which is less than 1. Therefore, the output will be 1 divided by 1 minus half. That means this is existing. The summation is converging. The sum is converging. Okay. Now let us consider y of minus 1. We have to check whether for the negative indexes also, whether there is any sample is existing or not. If for any negative index, the sample is existing in case of y, then we can comment about the causality of the system. So let's start with y of minus 1 and we'll check whether the summation is converging or not. So k is mod n. So mod of minus 1 to infinity 2 power minus k and uk. Therefore, k is equals to 1 as because it has passed through the mod operation. So 1 to infinity 2 to the power minus k uk. That means for this particular summation, we are actually focusing from we are not bothered about the sample at 0th position. So sample at 0th position we are not bothered about. So we'll start our sample from 1 upon 2, 1 upon 4, 1 upon 8, like this. So still the sequence is again decaying sequence, and any decaying sequence, as I already have shown, that the infinite GP series always it will converge. Therefore, the summation will exist. Therefore, in this case also we can see the summation will converge. Therefore, I can write that y of minus n is not equals to 0. Y of minus n, more precisely n equals to minus 1. Sorry, y of it will be n. Y of n with n equals to minus 1, that is for the negative index also, the sample is not 0. That means I can say the system, or sorry, the signal is non-causal signal. So the first part is done. Now we have to see that where is it? Okay, so now we need to see that whether the system is stable or not. So to check the stability, we know that stability condition. What is the stability condition? Let me write it over here. So stability. So if a sequence yn is given, so we'll take mod and then we'll sum all the values over n, and it should converge with the finite value which is less than infinity. So this is the condition of stability. Now we need to check whether the samples present in the signal is having what you call a decaying pattern or not. Decaying pattern or not. So for y equals to 0, so here they have written, I have written somewhere. So yes, so here we have seen that for index 0, for index 0, the summation is converging. So that means we are getting value. So I can see that the value is 1 divided by half. That means 2. And at y equals to for minus n condition, the summation, it will effectively lead to mm, half 1 upon 4, 1 upon 8, and the summation will go. So I can take half common, and then I can write it like this: 1 plus half 1 upon 4, like that. Therefore, I can see again there is a GP series is forming, and I can write it as half into 1 divided by 1 minus half. So half, so 2 will go up, and this is 1. Therefore, the system is bounded with the sample values. Therefore, we can see that the system is bounded with the sample values, and if you go beyond also, the sample values will start decreasing. Therefore, I can say the PBO stability, that is the bounded input, bounded output stability, is conserved. Therefore, the system is predicted as stable system. So this system is non-causal, that we have already seen that the system is having some values for the negative indexes also. Therefore, the system is non-causal, and the system is following the property of the bounded input, bounded output stability. So therefore, in this way, the system is we can call it as a stable system with non-causal components inside it. Now, in the next question, we can see that there is a system given, and we need to find the impulse response of the system. So what is an impulse response? So given an input xn, if a system has t, and let us consider if we employ a delta signal over here, then output is t of xn, and we know that t of xn is basically a convolution operation. As in general, we talk about the linear time invariant system. So therefore, if we apply t of delta n, it will effectively lead to the impulse response of the system, or the unit samples response of the system, when we provide delta n as the input. Now we need to find, so this is a composite system. So let me just draw a boundary over here. So this is a composite system. So now in this particular composite system, we'll provide an input over here at this end, and we'll get an output at this particular end. And we need to find the HN of the system, or the system impulse response. So now we can start solving the particular question. So let's start from this particular point. So xn is coming, and then it is convolving with h1n. and then it is multiply, and here let me just draw it like this, xn, and it is convolved with 2 into xn, and this is xn convolved with h1n, and then these two are added. That means at this particular location, the output is xn convolved with h1n plus 2 into x1n, sorry, 2 into xn. Okay. Then after that, we are again doing a convolution operation with this whole thing, that is h2n. And this is how we are getting y of n. And if I take xn out of the system, so I will get it like this, y of n is equals to xn convolved with h1n convolved with h2n. Okay, then I will get 2 into xn convolved with h2n. So this is what I am getting after opening this particular bracket. And then I can write it like this, that is h1n convolved with h2n plus 2 into so here I can write it like this. So this one is x1n h1n convolved with h2n, and this will directly go to x1n convolved with this. So it will be h2n, and there will be a whole convolution operation, as because convolution operation is commutative in nature, you can convolve the sequence like x1n x1n convolved with x2n, and I can equivalently write it as x2n convolved with x1n. That is what we know from the property of any convolution system. So this whole thing I can write it as, I can say that this is, I can say this is the effective system impulse response. Therefore, I can start solving this particular equation to get the final response, which is as, let me try to copy this section first. I don't know whether it will be copied or not. So the system is, it is not getting copies. Okay, no problem, I will try it. So it was beta into n plus 2, beta into x of n plus 2, and then here there was a multiplexer. Okay, and then we have summation over here. So there is a summation, and we can see that there is alpha to the power n delta of n minus 3, alpha to the power n delta of n minus 3, and this is what the system looks like. So I can start writing the equations. So it will be 2 into, so the multiplexer has, the input is 2. So it will start with 2 plus beta delta n minus 1. So 2 con alpha to the power n delta n minus 3 and beta with delta n plus 2 convolved with alpha to the power n delta n minus 3. So the property is that xn is convolved with delta n, then I will get xn. And if x of n minus k is convolved with, if xn is now convolved with delta n minus k, then I will get x evaluated at n minus k. Now with this particular property, we can start solving this particular sequence. Let us consider, let alpha to the power n delta n minus 3 is x of n for a matter. Then we are taking a convolution with delta n plus 2. That means alpha n delta n minus 3, which is effectively, I can write it as xn is convolved with delta n plus 2. Then I will get x of n evaluated or shifted by an amount of the same thing that is there in the convolution system. So I can write it like this: alpha evaluated at alpha evaluated at n plus 2 and delta n minus 3, and I can see that there is a plus sign over here, so this is delta n minus 3 plus 2 is one questions. Now let us go for the week 2 questions. So in the week 2, the main theme was DTFT, discrete time Fourier transform, and several properties which are related with the discrete time Fourier transform. So let us start solving the DTFT part questions. So in the DTFT part question, the first one is x e power j omega is the DTFT of a sequence xn, and the DTFT is given. We need to find the DTFT of x of n and x star of minus n. So for that, x of n has DTFT of x e power j omega. We need to find what is the DTFT of x star of minus n. So we need to find x star of minus n. What is the DTFT of that? So by definition of DTFT, x of minus n. Okay. Okay. X of minus n and e to the power minus j omega n, and n is running from minus infinity to infinity. So I can take the conjugation operation in a composite form, that is x of minus n e to the power j omega n, and I can take a conjugation over here. And as because we know that conjugation of summation, I can take the whole thing out. So I can write it as minus infinity to infinity. So I am taking the conjugation operation at the outside. So minus infinity to infinite x of minus n e to the power j omega n, and then there is a convolution. Now let me replace the variables minus n with m. So I can see that when n is going to infinity, m will be minus infinity, and when n is minus infinity, m will be plus infinity. So therefore I can write it as m is running from plus infinity to minus infinity, and I can say that this is m e to the power minus j omega m with a conjugation operation. Now summing the signal from, so let us consider if this is a signal xn, which is present over in both the negative side and the positive side. So if I am summing the signal from this side to this side or this side to this side, effectively lead to the same result. So I can write it as, so this is coming in the known DTFT form of given signal xn. So I can write it as x e power j omega, and uh, mm, so there will be x e power j omega, and there is a conjugation operation associated with that. So I can write it as x star e power j omega. Uh, I guess Ritesh Kumar, can you please turn off your mic? Your mic is on, otherwise. Okay. Okay, thank you. Okay, so we have got the corresponding DTFT of x star n. So I can get it as x star of e power j omega. And the question says that xn plus x star n, and we need to take the DTFT of this thing. So DTFT, I can take individual DTFT, and I can then take summation. So DTFT of x of n plus DTFT of x star of n. So therefore, the DTFT is like x e power j omega and x star e power j omega. So we know that, let us consider z is equals to a plus jb, and z star we know that a minus jb. So if I add z and z star, I will get 2 into a, that is 2 into real part of z. Therefore, in this particular equation also, let me just copy this thing over here. So in this case, 2, the equation is like this: x of n plus x star of n, and I have to take the DTFT. So these are just the summation of a complex number with a conjugate of that part. So I will get 2 into real part of x e power j omega. So here I can see that this is 2 into real x e power j omega. So this is the correct answer. Okay, so the next question is, the analog signal has two components, that is the cos component. So the cos component is having the frequencies of 5 kilohertz. So I can say that, let us consider a cos 2 pi omega into t. So this omega is basically 5 into 10 power 3, that means 5 kilohertz. So omega 1 is 5 kilohertz, and we can see that omega 2 has 9 kilohertz frequency responses. And the signal is sampled at a sampling rate of 7 kilohertz. And we are passing the signal, the final signal, with a cutoff frequency with a low pass filter, which has a cutoff frequency of 3 kilohertz. Then we need to find that in the output of the filter, what are the frequency components that are existing. So in the DTFT, in week 2, in the DTFT part, we have seen that what is the effect of sampling on a what is the effect of sampling of a analog signal or continuous time signal. So this is, let us consider this is XAT, and this has a, what you call, the frequency response. So this is Fourier transform of XAT, and I am taking the magnitude part only. Magnitude part only. And this is the frequency axis, and this is the omega r and omega minus r. Now, Okay, so in this case, if I sample the signal with a sampling rate of sigma s, then what is basically the effect? What is the effect on the digital domain signal? So the digital domain signal will have the baseband. So baseband will be followed, and the next bands will be shifted by the sigma s amount. So this will be sigma s. This will be minus sigma s. So the center frequency initially what was at zero. So initially the center frequency was at zero of the baseband. Now the baseband center frequency will be shifted to the multiples of sigma s. That means one baseband will be shifted to sigma s, another one will be shifted to minus sigma s, and I can write expand it into the uh, next baseband centers also minus 2 sigmas, and in this direction also the second baseband center frequency will be centered around 2 sigmas. So therefore, the digital domain signal, which will be sampled from the analog signal, will have this particular frequency spectrum response. So in this way, we can see that initially the signal had their the so this is the positive part of the spectrum. So we know that Fourier transform has dual property. So the whatever signal, whatever response is present in the positive domain, that will also be reflected in the negative side also. In this matter, we can see there are two particular frequency responses, 5 kilohertz and 9 kilohertz. Therefore, their corresponding images will also be there in the negative side, that is minus 5 and minus 9 kilohertz. So with this, let us consider for the first baseband case. So the sampled signal, I can write it like sampled signal will have the following properties in the frequency domain. So first property is baseband. Baseband. So baseband will have two frequency components, 5 kilohertz and 9 kilohertz, and their images at minus 5 kilohertz. Sorry, this is minus 5 only. So minus 5 kilohertz and minus 9 kilohertz. Similar like this, we have a frequency response over here. So the same frequency response is basically replicated in the negative half. So in this manner, so one in the baseband, the frequency responses will be minus 5 kilohertz, 9 kilohertz, and there will be their images in the left hand side also with minus 5 and 9 kilohertz frequency. Now, when the baseband is shifted, when the baseband is shifted to 7 kilohertz, as because we are sampling with a sampling rate of 7 kilohertz. So at that particular condition, the now the center has been shifted to 7 kilohertz. Therefore, the components will be 5 plus 7 kilohertz and 9 plus 7 kilohertz. For example, here only we can see that these components have been shifted by the same amount. If this is shifted by omega r plus delta sigma s, that means these components are also being shifted with the delta s amount in the positive direction. Therefore, the components are at 12 kilohertz and 16 kilohertz. Now, what about their images? Images. So image was at minus 5 plus 7 kilohertz and minus 9 plus uh, minus 9 plus 7 kilohertz. So I can see that this will be 2 kilohertz. Now, when the baseband is shifted to 14 kilohertz. So 14 kilohertz, this means that this is a multiple. I'm considering about the multiple basebands. For example, this one is the first baseband shifted by sigma s. Then the second band will be shifted to 2 into sigma s. Therefore, for that particular condition, so the original frequency responses that will be shifted by 5 plus 14 and 9 plus 14 kilohertz. That means it will be 19 and it will be 23 kilohertz. And what about their images? Images will be minus 5 plus 14 and minus 9 plus 14. So this will be 9 kilohertz and this will be 5 kilohertz. And okay, this one is minus 2 kilohertz. So this is 2 kilohertz and this is minus 2 kilohertz. Now we have got enough information. So we can see that for multiple value of 7 kilohertz, for let us consider for the second baseband, which is shifted by the frequency value of 14 kilohertz. Indeed, in that particular case, the impulses will be at 19 and 23 kilohertz and 9 and 5 kilohertz. Now the question is that after sampling the signal using the 7 kilohertz sampler, we are passing the signal through a low pass filter. This is a low pass filter and which has a cutoff frequency at 3 kilohertz. That means every frequency component beyond 3 kilohertz will be deleted and whatever components are residing inside 3 kilohertz, which are less than 3 kilohertz, that will be retained after passing it through a low pass filter. Therefore, we need to find that what are the frequency components that are basically there in the uh, uh, less than 3 kilohertz range. So we can see that we can see that initial components were residing in 5 kilohertz and 9 kilohertz, which are beyond 3 kilohertz, and these are the images. So I'm not bothered about the negative values. So negative values will just lead to the opposite spectra. Then in this particular case, again 12 kilohertz and 16 kilohertz. That means these are also beyond 3 kilohertz. These will also be deleted. Now we are getting something as 2 kilohertz. That means this component is residing. Okay, so this component is residing in 3 kilohertz range. That means even if we filter this particular sequence with a 3 kilohertz low pass filter with a cutoff frequency of 3 kilohertz, we can see that this particular impulse or the frequency response will be retained. Likewise, for 19 and 23 kilohertz, I can see that the frequency content will be deleted, and same as for 9 and 5 kilohertz. Again, this is beyond 3 kilohertz. That means the filter response is filter response will contain the 2 kilohertz output frequency component. That means the output frequency component will only have 2 kilohertz. Okay. Moving to the next question. So the next question states that yn is x of n plus 2. So this is what yn looks like. Now I have to draw y of n plus 2. Sorry, this is xn. So this is x of n and given is y of n is equals to x of n plus 2. So let me draw y of n and change the color as well. So this is the 0th point. This is the 0th point. Then I will get the samples like this sort. Okay, so 1, 2, 3, 4, 5, and I can see the negative samples as -1, -2, -3. At the fourth location, it will be 0, and at this particular location, it will be -5, -4. Okay, and the sample values are already given over here, so that's why so it will be 2. These guys will be 1, and these are of -1. So this is yn. And what is the property that we can see at this particular sequence, that yn is equals to x of n plus 2 is effectively following this particular relation. Y of n is equals to y of -n. That means whatever is coming over here in the positive side and whatever is coming over here in the negative side, they are effectively same thing. That means this is an even sequence. So this is the property that we can see over here. Okay, let me just get another page. So what we have been asked, so y power j omega is evaluated at pi location. So I can write it as y of n e to the power minus j omega n, and n is running from -infinity to infinity. Now the omega has been said that it is pi, so I can write yn e to the power minus j pi n. N equals to again -infinity to infinity, and I can write it as y e power j pi. Now e power minus j pi is cos pi minus j sin pi. So sin pi is 0 and cos pi is -1. So I can write e power minus j pi n as -1 whole to the power n. Therefore, if I calculate y e power j pi, it will be effectively reduced to y of n into minus of so it will be this. So it will be -1 to the power n. So therefore, let me just get the samples and I will correspondingly multiply each of the points with that. So in this case, I can see that the summation will lead to. So this is the sequence. So let me copy the sequence. Just create another page here. So the corresponding equation, governing equation is this one. So let's just copy this part also. And now we are ready to go with the final solution. So at 0th location, the output is 0. Then at the first location, it will be 1 multiplied with -1 to the power n, that is -1. Then at this location, this will be 2 into 1. Then at this particular location, it will be 3. So it will be 1 into 1 power -3. That means again -1. At 4th, it will be 0. And here it will be -1. And here also 1 to the power 5, -1 to the power 5. So -1 will effectively lead to 1. So we are done with this board. Now we need to see about this particular area. So here I can see that for -1 index, so for -1 index, it will be 1 into -1. So effectively it is -1. Then at this location, it will be 2 into there will be n equals to -2. Then even again, this is an even number, so it will yield 1. And then this is 1 into -3. That means -1. At the fourth location, it is 0. And here it is -1. And again, -1 to the power 5. Therefore, I can simplify this equation: -1 plus 2, -1 plus 1, -1 plus 2, -1 plus 1. So I can see that these two are cancelling each other. These two are cancelling each other. And -1, -1, 2. These are cancelling each other. So output is 2. So y e power j pi is 2. That is option B. Okay. So the next question is x e power j omega is so this is x of n, and we have to find x e power j omega, and effectively we need to find the angle present in x power j omega. So for that particular condition, in second week session, I had taken similar problem like this. So let's proceed with that only: x of n plus 2. And the sequence, you can see that this is the sequence, that is y of n is x of n plus 2. So this particular sequence has a property that is the even sequence. So let me start with this particular sequence, and then I will show that this particular sequence has very nice property in the DTFT domain that will help you to effectively find the output of this question of angle x e power j omega, or x e power star j omega rather. So this is what we need to find: x e power star j omega. So let's start with y e power j omega. Y e power j omega is n yn e to the power minus j omega n, and I can write it as y0 e power 0. Someone's joining. Okay, so it is y0 e power 0, and then I can write n equals to 1 to infinity yn e power minus j omega n, and similarly I can write y of n e power minus j omega n. Now the indexes will change: minus infinite to infinite. Now if I break the summation, I will get y e power j omega as y of 0, then y of 1 e to the power minus j omega, y of 2 e power minus 2 j omega, like that. And for the negative part, I will get y of minus n e to the power j omega, y of minus 2 e to the power minus 2 j omega, and like that. Therefore, there is another property we have already talked about in the last question, that y of minus n is n, as because it is an even sequence. Even sequence. So we can see that y of 1 and y of -1, they are effectively the same thing. So this particular summation, I can effectively write it as summation y of n, as because minus n index and y of n index, this will effectively lead to the same sample. So y of n e to the power minus j omega n, and n also I can write it from from 1 to infinity. And there will be a summation of e to the power j omega n, as because for the negative samples I am getting the positive response in the E. Therefore, I have taken the one-sided response, and I have clubbed these two particular exponents. So this will be 2 into uh, 2 into y of n cos omega n equals to 1 to infinity. Therefore, we can see this is a real thing, and this part also, this is a real part. That means the DTFT, we can see that DTFT comprises of both real and imaginary thing. But for this particular case, the DTFT is consisting only the real part. That means there is no imaginary part. And if there is no imaginary part, there will be no phase. There will be only magnitude. Magnitude. So therefore, uh, we know that x of n is equal y of n is equals to x of n plus 2. So if I take the DTFT in both the side, it will be y power j omega e to the power 2 j omega x e power j omega. So x e power j omega will have e to the power minus 2 j omega multiplied with, it will be y. So y e power j omega. Now if I take conjugate operation at both the sides, so x star e power j omega, it will be e 2 j omega by e power j omega. Therefore, if I take angle, so angle x star e j omega, so this has an angle of 2 omega. However, this has zero angle, as because I have already said that this is consisting only the real part. Therefore, it contains only magnitudes. There is no phase. That means phase corresponding to this particular thing is zero. Therefore, 2 omega plus 0. So the output is angle x star e j omega will have an angle of 2 omega. So this is the correct answer. There is 2 omega. Okay. Uh, So in this question, again, xn is given and yn is x of n minus 5. That means each and every sample will be shifted in the right hand side with the amount of 5. So with this particular uh, um, uh, operation, we can start solving the question. So the question says that we need to find the integral value y e power j omega mod square d omega. And we know by Parseval's theorem that what do you call it? Y e power j omega. That means in the frequency domain, the energy 1 upon 2 pi from minus pi to pi d omega is equivalent to summation y of n whole square. That means energy in both the domain, energies are proportionate with each other with a constant multiplier of 1 upon 2 pi minus infinity to infinity. So we need to find this particular integral. Therefore, y e power j omega whole square d omega running from minus infinity minus pi to pi, it will be 2 pi multiplied with y of n mod square n equals to minus infinity to infinity. Therefore, I need to draw yn equals to x of n minus 5. So each and every sample will be shifted in the right hand side with a unit of 5. Therefore, the signal, so this will be shifted to 12. So this is 12 and here it will be shifted with plus 5. So range will be at 2. So from here the samples will start. So this, then 0, then 1, then I will get a 2 over here, 1, then 0, then 1, then 2, then 1, then there will be a 0, and here is the last sample. Okay, so this is y of n with a sample of n. So 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Okay, so this has been shifted with a, this has been delayed by delay by 5 unit. Now we need to find the summation, that is 2 pi into all the samples we will take mod of that, and then we'll take square, and then we'll add all the samples. So these are at -1 position. So this is 1, 0, 1, 4, 1, 0, 1, 4, 1, 0, and 1. So let me just add up all the values. So to church or short out. So this is 14. So this will be 28 pi. So this is the final answer. That is 28 pi. So now we are done with the week 2 questions. Now we are left with the week 3 part. So let's start solving the week 3 quiz. So in week 3, the main uh, topic was the rational system plus Z transform. So in rational system, we already have talked about what is the steady state response, what is the transient response. We have seen that steady state response basically yields to a linear system, time invariant system. However, the transient system is not transient system, as well as it is not a linear system, which will effectively lead that the rational system in a whole, it is not a LTI system. And there is Z transform is associated with that to check the stability, the poles location, and we'll talk about the ROCs also. We had already discussed all these things. So let's go to the questions for the week 3. So in week 3, so let me first take this question. So there is a causal LTI system with the input of xn and output is yn, and these are related with this particular equation, and then we need to find h of 0. That means we need to find the impulse response at 0 position. So let's start with the equation. So yn, and this is alpha k, y of n minus k, and k is running from 1 to 10. Then it is equated with x of n and beta x of n minus 1. Okay. So sorry, this is beta. Now let's take Z transform in both the sides. So if I take Z transform, I will get x of y of z, then summation alpha k. So I can say there is a shift in the right side. So it will be z to the power minus k y z, and k is running from 1 to 10 again. So this is xz, and beta multiplied with z to the power minus 1 x of z. So if I take y of z, ratio of y of z and x of z, I will get the system impulse response, and I will get the Z transform of the system impulse response. So I can write it as 1 plus beta Z inverse, and this thing I can write it as 1 plus alpha k Z to the power minus k, and yz already I have taken out. So this is k equals to 1. So this is what hz looks like. Hz is this thing. So hz is this particular thing. Now we need to find h of n evaluated at n equals to 0. So effectively, if one starts with like, okay, this is the Z transform, I will find the inverse Z transform, and then I will put n equals to 0. It will take ages to solve this particular question. So there is a quick method to solve these things. So h of n equals to 0. That means we are trying to find the initial response. So corresponding to that, we have a theorem. The theorem is initial value theorem. Initial value theorem. In the last class, I had already proved that how the initial theorem basically gives you the evaluation at n equals to 0. So this is limit. So limit n tends to 0, h of n, which is effectively h of 0. This is limit z tends to infinity h of z. So you can check the last class to and you can get the derivation of this particular initial value theorem over there in the last video lecture. So h of 0 will be limit z tends to infinity. And let me just paste this thing. So this is the sequence. So I can see that 1 plus beta into 1 upon infinity is 0. So 1 upon beta into 0. And I can see that in each and every cases, whatever the case, so z is in the form of z to the power minus k. That means 1 upon z to the power k. That means if we put z equals to infinity, then this whole thing will lead to 0. Therefore, the summation of this whole thing is 0, k equals to 1 to 10. That means this whole component will lead to 0. Therefore, 1 is the final answer. So h of 0 is 1. That means this is the final answer. Okay, so this question, in the question, it is written that xn has the following characteristics. Xn has the z transform as xz with poles residing at plus j by 2 and minus j by 2. Now the question is that the sequence minus j to the power n x of minus n will have poles at what are the locations. So let us consider y of n is equals to minus j to the power n x of n. Now let me just try to find the z transform of this particular sequence. So it will be minus j to the power n xn z to the power minus n, and n is running from minus infinity to infinity. So I can write it like this: x of n z uh, divided by j, and this is j to the power n. So I can take minus j to the power minus n. Okay, and I can write it as minus infinity to infinity. And the sequence is actually x of n minus z by j to the power minus n. Therefore, I can take y of, okay, let me just remove this part. Okay, so I can write y of z is now effectively reduced to x of n z by minus j to the power minus n, and n is running from minus infinity to infinity. So this is coming into a form of a z transform again. So I can take this thing inside like z by minus j as z prime. So I can write xn z time to the power minus n. N is running from minus infinity to infinity. So this is effectively leads to x z prime. So this is also a z transform. Now the argument inside this x z star is now effectively z divided by so I can take it as z minus j. Let me multiply j in both the places. So I can write it as z star is equals to j squared will be minus 1. So it will be j into z. That means y of z is equals to j multiplied with z. Now in the question it was written that x of z had poles at these two locations. That means the transfer function would look like z minus j by 2 and z plus j by 2. However, in this particular case, yz, as it is written as xjz, that means the argument is will replaced by j into z. Therefore, the transfer function corresponding to this z transform will effectively converted to all the z terms will be replaced by j into z, and then the locations will be just the same, like it will be plus j2. Now I can get the pole location for the sequence yn. So let me just copy this thing. Okay, so this is the y part, and I need to find the poles of yn, which is -1 to the power n x of uh, n. Therefore, the poles I can get by denominator of z is equals to 0. That means jz minus j by 2 is 0, and the second condition is jz plus j by 2 is equals to 0. Therefore, z I can write it as half, and here I can write it as z is equals to minus half. That means in the second system, the pole locations are half and minus half. So let's check. So it is okay. So this, oh, sorry, it was x of minus n. Sorry, sorry. So I have done the whole calculation while keeping x of n. So uh, let me, I will just give you the hint. So this will be the same thing. Instead of n, you have to take minus n, and then you have to just change the variables. Let me just give you some brief idea, and you can do the same process. Like you will start with x of minus n, and then you will get some z transform representation, and then you need to just change this particular argument with the initial argument. So initially, this is the initial Z transform, initial Z transform based transfer function. I'm writing it in short, that is transfer function. So you just need to change the argument with the corresponding Z transform. So you will start with y e y z as -1 to the power n x of minus n e power. Sorry, this will be z to the power minus n. This is z to the power minus n. Then, sorry, this is g. So then I can write it as minus n z minus j to the power minus n. N is equals to minus infinity to infinity. Then I can take minus n equals to m, and then the what you call the or the limits will be m is equals to from minus infinity to plus infinity, and correspondingly all these operations will also change, and you can effectively get down to z transform representation, and then you can do the same operation to get the final answer for this question. So I have given a hint, and you can use that hint and you can get the solution for this. Okay, so moving forward with the third question, the question is that yn is equals to half y of n minus 1. So mind it that I have solved the question with x of n. So it was x of minus n. I just have missed the negative term. So you can do it by yourself, as because I have given the explanation that how to deal with this kind of systems, and you can get down effectively get down to find the corresponding Z transform. And from that Z transform, you can get the transfer function reformed, and you can find the what you call the pole locations. So yn is equals to half yn plus x of n, and the initial condition is given as y of -1 is equals to 1. Okay, so and the input is xn is equals to un. Then we need to find the system response. We need to find the system response. So this is in the last week we had already discussed in detail that this is a ordinary constant coefficient difference equation system. So the difference equation, if you solve any difference equation, or in general, if this was in the analog domain, then in the difference equation will effectively convert into differential equation. So differential equation or difference equation, any of those had two particular solutions. One is called the transient solution and another is basically the steady state solution. So here also y total n, or the final output, will be a summation of y steady state n and y transient n. So we need to find both the responses, the transient response as well as the what we call the steady state response. So in case of transient response, I have to make another remark, is that in case of transient response, input will be considered as 0. That means there will be no input. And in case of steady state response, the initial condition will be held to 0. Initial condition will be held to 0. There are two conditions that we have to consider to find the corresponding solutions. So let us start finding the transient solution first. Transient solution. So for transient solution, I can write yn minus half of y of n minus 1 is equals to 0. Y equals to 0 as because we already have told that input will be considered as 0. That means xn is 0. Now let's try to find the ytr at 0. So the equation is yn minus half of yn minus 1 is equals to 0. So y transient equals to 0 will effectively lead to half y of minus 1, which is half into, so the value is given as, half, 1. So half into 1, that will be this. Now y transient 1, it will be effectively lead to that half into, that will be half into y tr. So if we put n equals to 1, then it will be 0. That means y tr 0 will be half into half. That means 1 upon 2 squared. Okay, this will be 1 upon 2 squared. I guess there is some error. Okay, so this is shifted over here. Okay, yes. Now I can say that y tr at second position, it will be given as half into or from here itself I can see the relation. So when n index is 0, when n index is 1, we can see the here the index is basically incremented by 1. So y tr n is equals to 1 upon 2 n plus 1. That means if we put 0 over here, then it will be half. When we'll put 1 over here, we'll get 1 upon 2 square. That means this is the response for the transient solution. Now we need to find the steady state response. So to get the steady state response, we need to consider initial conditions is equals to 0. Therefore, y of n minus half y of n minus 1 is equals to x of n. So I can take z transform in both the sides. So yz minus half z inverse yz, and this is xz. So yz is effectively 1 divided by 1 minus half z inverse multiplied with xz. So let me change color over here. Otherwise, this way this is also looking like x. So let me put this thing on top. So this is xz. Now the given sequence is xn is equals to un. So xz, we know that this is 1 minus z inverse. So this is the property that we know that un has this particular z transform. So it will be 1 divided by 1 minus half. This will be 1 minus half z inverse multiplied with 1 minus z inverse. So that means now we have got the composite Z transform representation, and as because we are talking about the steady state response, and in steady state response we know that we can take Z transform and we can create the impulse response as because it's an LTI system. Therefore, this YZ is effectively the steady state response. So if I calculate the inverse Z transform of this YZ, I will get YSSN. So let us find the YSSN. So I need one page. Okay. So let me just copy this part. So the corresponding equation is this one. So we need to find the uh, inverse Z transform of this particular equation. So numerator is 1. So I can write it as 1 divided by 1 minus half Z inverse and plus B 1 minus Z inverse. Okay. So A, I will be calculating using YZ multiplied with the same factor at which I'm getting the singularity of Z inverse, and Z will be evaluated at. So let us consider to find the poles of the system, poles of YZ. So the poles of YZ are at Z equals to half and at Z equals to 1. So at these two positions, we are getting the poles. Now, to evaluate A, I will be needing the whole half as because at that particular location I'm getting the singularity. Therefore, it will be effectively 1 minus. Uh, so this will be 1 minus 2 as because this is inverse. There is inverse Z inverse is there, and I'm taking the pole at 1 upon 2. So Z inverse will be effectively lead to 2. So this is at minus 1. And let me take another sequence that is for B. So B will be YZ multiplied with 1 minus Z inverse factor, and the pole is at 1. So at that particular condition, that will be 1 minus half. So this will effectively be 1 minus half is half, and 2 will go up. So A is equals to minus 1, B is equals to 2. Therefore, the Z transform, if I uh, do the partial fractions, so I will get uh, minus 1 divided by 1 minus half Z inverse, and this will be 2 1 minus Z inverse. Now let's take the inverse Z transform. So let me start with this part. So this will be 2 into UN. UN has the Z transform of 1 minus Z inverse, and this will be minus 1 by 2 to the power n into UN. So this is from the property. So this is the YSSN. So Y total n, and we have been told that n greater than equals to 0. We need to consider. So for n greater than equals to 0, we know that UN has sample value of 1. So I can write it as 2 minus half to the power n. Half to the power n. This will be n. Sorry. To the power n. So this is Y steady state n at n greater or equals to 0. Therefore, total n, so Y total n is equals to Y steady state n plus Y transient n. So this will be 2 minus half to the power n, and then we'll have half to the power n plus 1. Therefore, if I solve these particular things, so I will get 2 minus half to the power n. Let's take common, and then I will get 1 minus half. So it will be, let's take one more page, and it will be 2 minus half to the power n, 1 minus half. So this will be 2 minus half into half to the power n, or 2 minus 1 by 2 whole to the power n plus 1. So let me see the solutions, also the options. So our solution is 2 minus half to the power n plus 1. So this is effectively the option C. So option C is the correct answer for this question. Okay. So next question is, there have been given a Z transform. So HZ is given, which has the following response: 3 divided by Z minus 1 upon 4 minus 1 upon 8 Z inverse. And we need to find the inverse Z transform given the fact that Hn is a causal sequence. That means while taking the inverse transform, we need to maintain the sequence in such a manner so that the output sequence that we are getting from the inverse Z transform will have causality property. That means for the negative side of index, there will be no component in the signal. So let's start do the partial fraction of this thing. So before that, let me take Z out, one Z out from this denominator. So it will effectively lead to 3 Z inverse, 1 minus 4 Z inverse, and 1 upon 8 Z to the power minus 2. So I can take it like this. 1 plus 1 upon 4 Z inverse minus 1 upon 2 Z inverse minus 1 upon 8 Z to the power minus 2, and there will be 3 Z inverse. So I can write it as 1 plus 1 upon 4 Z inverse, and I can write it as 1 minus half Z inverse. And here it is 3 Z inverse. So this is what is h of z looks like. So I can again do partial fractions. That will be a divided by 1 plus 1 upon 4 z inverse plus b divided by 1 minus half z inverse. Now let me find a and b. So a will be hz multiplied with 1 plus 1 upon 4 z inverse. For example, this is where we are getting the singularity, and z will be evaluated at minus 1 upon 4, minus 1 upon 4, because poles is basically decided at minus 1 by 4 in this particular case, where I'm getting the singularity in the rational system. Now, if I multiply this with this term, so these two will cancel each other, and I will effectively get 3 into minus 4 divided by 1 minus half into minus 4. So that means it will give me minus 3 into 4 divided by, this will effectively plus, so 3. So cancelling each other, a is equals to minus 4. Similarly, let me find b. B is hz multiplied with 1 minus half z inverse. So 1 minus half, and z is evaluated at the position half because the pole is residing at half location. Therefore, the final thing would look like 3 into 2, then 1 plus 1 by 4, 1 plus 1 upon 4 into 2. So this will be 3 into 2 divided by, this will be 2, 3 by 2 again, and this will be 3 into 2 into 2 by 3. So 3 cancels each other. Okay. So effectively the partial fraction will look like, so let me just copy this thing over here. So A we have evaluated is like A is equals to -4 and B is equals to 4. Therefore, I can replace the values with the corresponding evaluated ones. Okay. Now still we are now at a position to get the inverse Z transform, that is H of n. So I will take individual inverse Z transform and I will just add it up. So H of n will be -4. This will be -1 upon 4 to the power n un, as because uh, we have already given in the question that the sequence output sequence should be causal. Therefore, if I only choose -1 upon 4 at the -1 upon 4 for this A, because as per the properties, a to the power n un have the following Z transform 1 minus a Z inverse. Therefore, I need to choose that A is -1 by 4. Followed by that, there will be 4 and it will be half to the power n un. Therefore, the solution is this one, and let us check what is the options that is being given for this question. So -4 -1 by 4, and okay, so this one is the correct one. So option C is correct. So this is option C. Okay. Now, this is the question 5 or the last question for this week 3 quiz. So here it is basically HZ is 1 divided by 1 minus 2 Z inverse multiplied with 1 minus half Z inverse. And we have been given some ROCs and we need to determine some ROCs are given in the options and we need to determine the region of convergence for this particular transfer function. So the poles location, let us find what are the poles location. So 1 minus 2 by Z is equals to 0. So that means Z is equals to 2. And here it is 1 minus 2Z is equals to 0. That means Z is equals to half. So if I draw the Z plane, so there will be two positions. One will be half, one will be 2, and they will have the corresponding circular representations in the Z transform like this. Okay. And let me draw the unit circle also. So this is the unit circle location. Pardon my drawing, these are not proper. So this is unit circle and these are the pole locations, that is -2 and half. So in the question they have given two statements, that is one is stable, one is anti-causal. What is stable means? Stable means that ROC should enclose unit circle, unit circle, whereas the anti-causality means that your ROC is converging in nature, converging in nature. That means it will come inside. It will not go outside of the pole location. Therefore, as per the statement is given, stable but anti-causal. So to get the, let us check with the options, which will be the correct one. So mod Z is greater than half. So the first thing is mod Z is greater than half. That means the ROC will go outside. However, ROC cannot go outside because this is an anti-causal system. For anti-causal system, that means this is an anti-causal system for which only for the negative samples the sample value will exist. So in this particular case, we had seen in the week 3 content itself that right-handed sequence will only have their ROC going outside of the pole location. However, in the left-sided sequence have the ROC in the converging nature. That means it will come inside. Okay, so in this manner, the option A could not be the correct answer as because the system is anti-causal. Okay. then mod z is less than 2. So mod z is less than 2. Okay, that means it will uh, go inside. The ROC will go inside. But here also there will be a problem, because if mod z is less than 2, that means this is covering this area also. So ROC cannot contain any pool. So this one is also not the correct answer, because ROC cannot contain any pool. And here the reason was system is anti-causal. Anti-causal. Okay. Now, so this one, option B, is also not correct. Now let us consider the third case. So the third case is mod z is in between half and 2. So half and 2 means the ROC will be basically this particular region. Now, if ROC is the annular region, ROC is basically the middle region of these two concentric circles, which we call as annular region. So in case of annular region, we know that if only the system is both-sided sequence, then only we get an annular region as a ROC. Therefore, the question we have already told that this is an anti-causal sequence. Therefore, this is not an both side sequence. That means this option is also nullified. That means we are left with the none of the above. So the final answer would be none of the above. So in this way, we need to proceed for these kind of questions. If anyone starts with, okay, the Z transform is given, and we'll start to find the inverse Z transform, and then we'll check what is the ROC, that will effectively lead to take longer amount of time to solve this particular question. So we need to work smartly, and we need to play with the options itself to get the final result. So in this way, with the option itself, we can see that the final answer is none of the above. Okay, so so we have already talked about the week 1, week 2, and week 3 quiz questions. Now, initially I told that we will have some recap. So I guess time will not permit to have some recap, but still we can directly jump into week 4 numericals. So in week 4, the main content was the DFT, that is discrete time Fourier transform, which is a sampled version of DTFT, that is the sample version of DTFT, and associated with that we'll see several properties of DFT, and then we have seen what is called circular shift as well as circular convolution. So in the week 4 quiz, you will see problems related to DFT and circular shift and circular convolution. I will take 2 to 3 problems which may be helpful to solve the week 4 question. So let's start with the problem for week 4. So in case of uh, week 4 question, let me just see within how many questions I have. Okay, so the question is given as x of n is having a z transform of xz, where ROC is given as mod z is less than 2, and we need to find the z transform of x star of minus n. So let yn is equals to x star of minus n, then the z transform we need to find. So yz is equals to summation x star of minus n, z to the power minus n is running from minus infinite to the infinite, and then I can write it as xn, and here I can do some manipulation to take the so let's first take the conjugate operation. Let's first take the conjugate operation out of this particular multiplication. So I can write it as uh, z 1 upon so we know that if there is a conjugate x z, and if we take a conjugate on top of this particular complex variable, we'll get the output as simple z. So I can take it as z conjugate of minus n, and then I can take the conjugate out. And as because we know that the conjugate property, I can take the whole conjugate outside of the system. So it will be z to the power minus n, and then evaluating the whole conjugate. Therefore, we can see that this is also a Z transform. So this will be just x of uh, uh, this. Okay, sorry. So there is minus n also associated with this thing. So we need to change some variables over here. Okay, so I can write it as, let's say, minus m is equals to m. So the summation will be on m now. So it will be x of m and then z star of m. Then I can take the whole thing out and let us consider the summation is now on m x of m. Now I can do some manipulation over here again. So the manipulation could be 1 upon z star, and then let's take minus n. So this will be effectively z minus 1. Then I'm taking star, and then again the power is minus m. So minus minus will cancel with each other. So it will be effectively z to the power m. Okay. So in this way I have done the manipulation. So let's consider this whole thing outside the star. So again, this is now a z transform. So the z transform is effectively 1 upon z star, and there is another conjugate operation is waiting outside. So this will be x star 1 by z star. So y of z is x star 1 upon z star. So moving with the next question. Next question is, we have given an endpoint sequence xn, and let us define a new sequence yn is equals to x star n, and the DTFTs are given as xk and yk respectively with endpoint DFTs. And then we need to find what is the relation with the corresponding signals DTFT. Sorry, DFT. So given yn is equals to x star n, so the DFT will be effectively yk summation will go from x summation xn e to the power minus j 2 pi k n divided by capital N, as because we are running with n minus n point DFT. And the variable is running from 0 to n minus 1, as because we have n number of samples in the segment. Okay, so the first thing that we need to find that k equals to 0, what is the relation? So n minus 1 and n equals to 0, that is x star of n and e to the power 0. So that is x star n equals to 0 to n minus 1. I can take xn the conjugate outside, and n is running from n equals to 0 to, so this is n is minus 1. So that means I can write, and the, let's say, x of 0, that means DFT of x of 0 is basically xk e to the power 0, and n is running from n minus 1. So that means this is xk n equals to 0 to n minus 1. So I can see that this operation is coming over here. So I can replace this thing with x of 0. Outside there is a conjugate operation, that means x star of 0. Therefore, y of 0 is effectively x star of 0. So this is the final answer. That means either these two options will be correct. So these later options are already nullified. because the first option, because the second one is already nullified with the y0 is equals to x star 0. Now we need to find the second part, that is y of n is equals to x star of n, and we need to find yk, the compact representation, n equals to 0 to n minus 1, then x star of n e to the power minus j 2 pi k n divided by capital N. Now let me take the conjugate operation outside. So n is equals to 0 to n minus 1, x of n e to the power j 2 pi k n divided by capital N, and there will be a conjugate operation over here. Now I can write it as n equals to 0 to n minus 1, x of n e to the power j 2 pi k n by n multiplied with e to the power minus j 2 pi k n by n. So this will be effectively 1, so I can just multiply this thing. Now for this case, it will be x n, and I can write it as e to the power minus 2j n, and this is n minus k divided by n, and I can write the conjugate outside again. So with this I can see that xn has xk, and the representation is DFT representation is summation xn e to the power minus 2 pi k n by capital N, and here instead of that, here instead of k we are getting n minus k, so I can write it as DFT n minus k, and there is a conjugate outside, so I can write it as x star n minus k. So this is the final answer. So option A is the correct option. Okay. So the final question is x of n is equals to 2, 1, 2, 1. And there is another sequence h of n which has 1, 2, 3, 4. So we need to find a circular convolution. So let me tell you two properties of circular convolution. Circular convolution, let us consider xn has uh, n number of points and hn has m number of points. So circular convolution output will have, let's say yn is the circular convolution output. The number of samples it will have n comma n maximum. So in this particular case, there are 4 samples in each of the cases. So it will be maximum of 4 comma 4. That means output sequence will have only uh, uh, only 4 samples in the output space. So in the theory class, we have seen the circular convolution requires a huge number of operations. You need to first fix a signal, then fix a period. Then you can actually take the copies of the periods, and then you can shift the signal, then invert the signal, and then you can multiply it with the original with the other sequence to get the circular convolution done. However, this process will take ages to solve the questions in the exam. Therefore, we need some shortcut techniques to solve the circular convolution techniques. So this is a shortcut technique. So how we can proceed? Like we'll multiply each of the samples with the multiplier. So this will be, I'm multiplying 1 with the whole sequence. So 2, 1, 2, 1. Second thing will be 2 multiplied with whole thing. So that is 4. Then 2, 4, 2. Then 3 will be multiplied with this whole thing. That will be 6, 3, 6, 3. And then again, this will be, and I'm shifting also. I'm shifting 1 unit in each and every cases. So in this particular case, this will be 8, 4, 8, 4. Now I will sum up all these things. So if I sum up all these things, it will be 2, then 5, then 10, then it will be then it will be 16, it will be 12, it will be 11, and it will be 4. So already I told that the output sequence will only have 4 samples. So here I can see that initial 4 samples are this one. So these are the extra samples. So what I will do, I will append these samples below this and I will add again. So I will add 12, 11, and there will be 4. And as because there is nothing, I will write 0 over here. So the final output will be, so this will be 14, 16, 14, 16. So output will be 14, 16, 14, 16. So you can find as so if you've been given as very big sequence also, so you can find the whole output using this particular method. We'll multiply each of the elements with the multiplier and then shift. And likewise, I will do the operation for each of the elements and then I will sum it up and I will check that what will be the number of samples in the output sequence. And if it is exceeding, then I will just append it below the original number of samples that is desired in the output sequence, and then I will add it up. So here I am adding up. So in this way, I will get the circular convolution for this particular question, and the output is matching with option B. So option B is the correct answer for this circular convolution operation. So with this, I guess we have covered the whole week 1, week 2, and week 3 questions, and I have given the solutions as well. And for your reference, I will upload the video as well as I will upload this slide link in the video description itself. So from the description, you can just you can just download the slides and then you can check the solutions. So if any query is there, you can please unmute yourself and ask. Any
Yeah, sir.
queries?
I sir, I couldn't able to attend the previous sessions. So where do I find that videos?
Okay. Let me show you. Many people were asking that question. Let me show you how to uh, get the videos. So you will search the course link. So this is the course link, NOC 23132. So you'll go to the course and then you can see the problem solving sessions. Just click it over here, then problem solving recording. So you click over here, then one Google Sheet will come. So in the Google Sheet, each and every week, whatever class I am taking, I am uploading it in YouTube and the corresponding links will be updated on this particular sheet itself. And the presentation slides that I'm showing in the live sessions, I'm uploading these in this particular Google Drive link. So you can access both the YouTube link and the presentation link to get these slides as well as the video lectures.
Okay, sir. Thank you, sir.
Okay, any further queries? Okay, so it seems there's no further question is there. So let me just save it. Okay, then let me stop the session over here and thank you for joining the session. So I will be conducting the session in every Friday from 6 to 8. And if you have any further queries, you can post your question in the NPTEL discussion forum and I will try to solve the questions over there as well. And if any particular queries there related to any of the solutions, I can take the question again in the live session and I will solve that question itself here in the live session too. So thank you for joining. So let me stop the recording. Okay.